How does load line analysis work for electrical engineers? Imagine you're trying to find the perfect spot where a transistor or diode works best in a circuit. That's where load line analysis comes into play. It's like drawing a map to see where the device operates most smoothly. This method helps engineers see how voltage and current work together in nonlinear devices. Think of it as a way to find the device's steady state, called the operating point or Q point. To do this, engineers start by plotting two key things on a graph. First is the device's characteristic curve, which shows how current and voltage relate for that specific component. For example, a transistor's collector current versus collector-emitter voltage, or a diode's forward current versus voltage. Second is the load line, which is a straight line representing the circuit's limits based on the power supply voltage and load resistance. This line shows all the possible combinations of current and voltage that the circuit can have. The load line is derived from the circuit's Kirchhoff voltage law, which states that the total voltage around a loop equals 0. The equation looks like this. Voltage equals the supply voltage minus the product of current and load resistance. When you rearrange it, it becomes a straight line on the graph. By plotting this line along with the device's nonlinear curve, the point where they intersect is the operating point. That's where the device actually runs in the circuit. Constructing the load line involves knowing the supply voltage and load resistance. For example, if the supply voltage is 100 volts and the load resistance is 1000 ohms, the load line equation becomes I equals 100 volts minus voltage, divided by 1000 ohms. Plotting this line on the graph helps visualize the possible current and voltage values. The intersection with the device's characteristic curve shows the steady state. This analysis is especially useful in amplifier design. It helps engineers set the bias point so the transistor operates in the linear region, avoiding cutoff or saturation. This way, the output signal remains clean and undistorted. For example, in a common emitter amplifier, the load line is drawn using the collector supply voltage and collector resistor. The intersection with the transistor's characteristic curves shows the collector current and voltage at the Q point. Load line analysis also applies to nonlinear components like light-emitting diodes and laser diodes. It helps determine the right operating voltage and current for these devices based on the load. Overall, this method allows engineers to predict how devices will behave in real circuits and make adjustments to improve performance. It's a simple yet powerful tool to ensure that amplifiers and other electronic components work reliably and efficiently within their limits.